Pigeon walks into a bar, puts $10 on the bar and says, "I'd like a drink." And the bartender's like, "Well, pigeons are pretty dumb, so I'm going to stiff him on this $10 here." And he gives him $1 back as his change and gives him his drink. And he's like, "Hey, we don't get too many pigeons in here ordering drinks." And the pigeon says, "At $9 a drink, I can see why."
I got you did a fine job.
Man, now my pigeons are all making cooing noises. I'm going to be muting myself on and off on this one here.
You'll be Teenage Mutant Ninja Turtle, yeah.
Teenage Mutant. Hi, Ed.
Hey, Ed.
Hi there.
Thanks for coming on. This is going to be fun.
Good.
Yeah, I'll definitely be sharing some of those videos. And so
That'll be ideal because, a picture's worth 1,000 words, and I don't have 1,000 words to describe those pictures.
I'll tell you, some of those, when they're talking about how would you separate these into two different groups, those graphs and stuff, it's like, I don't know. Like, they all look so similar. I don't know how you would
exactly.
do that.
Well,
But,
and that's the thing that the birds can do. I wasn't so sure they could learn that very last task. That one I invented that so that it would be nearly impossible. But the birds actually made it possible. They could do it.
That's awesome. I mean, like one of the reasons we wanted to bring you on is because you hear, we really promote everything pigeon. And whenever you meet kind of the pigeon people, they're always, pigeons are underappreciated and they're so much smarter than people give them credit for. And, I read this article online that pigeons can do this, this, and this. And I'm like, well, let's get it right from the source here. Someone who's actually done studies with these and really shown some pretty interesting results. I mean, it's crazy to compare it to AI today, which is a really big thing right now.
It is, and it fits a narrative that is a peculiar one, that AI is supposedly so smart, and yet this mechanism that Pavlov started studying and that Skinner studied has always been dismissed as too elementary, too rigid, unable to contend with the complexities of the world. And it turns out that this mechanism is exactly the mechanism that we've programmed into computers that makes them look like they're smart. It's a real irony.
Did you guys do this test with any other kind of animals, or I guess how did you guys choose pigeons?
Well, the pigeon has been a favorite in behavioral laboratories since the late 1940s. Skinner began a fantastic project to use pigeons as the guidance system for ballistic missiles.
Right.
He put the plan was to put 3 of them into the nose cone of a rocket and have them be the guidance system, the smarts of the missile. And he arranged it so on a little screen, each of the pigeons would see, for example, a picture of a battleship. And as the pigeons drifted off course, they could bring it back on course by pecking at the battleship. And the idea was that with 3 of them, there would be redundancy in the system, and they would then hone in on the target. The Skinner tested this in a warehouse in Minneapolis, and the pigeons passed every test. It was funded by the military, but ultimately they just couldn't bring themselves to deploy pigeons in this deadly deed. And fearing, I'm sure, that if a missile were to go awry and word would get out that the military had enlisted pigeons in this wartime enterprise, that would be the end of their funding for some time.
Video about that where they were pecking a dot and they were following the dot around.
Yeah, well, they're quite able to do some things quite well.
Let's open this up here. Welcome to the All About Pigeons podcast. I'm Phil.
And I'm Chris.
Today we have with us Ed Wasserman from the University of Iowa. They've done some really interesting studies with pigeons and figured out some pretty amazing things about how intelligent a pigeon really is, even compared to today's AI. Thanks for coming on. I really appreciate you being here.
It's a pleasure chatting with you two.
So do you remember because I remember, like Chris saying, no, I've seen something about it too. Do you remember what that project was called when they had the pigeons with Skinner doing that?
Yeah, Project Orcon.
Or
It was an abbreviation of sorts for organic control, so that the pigeons were to direct a missile, and they would be the control system. It wouldn't be electronics, not in the usual sense of the term, although our brains are electronic devices. The birds, if given proper training, the trio of birds could direct a missile to a target, and lo and behold, Skinner and his associates found out that they could. They had then a good background in the techniques for providing reinforcement to the pigeons, depriving them of enough food so that they would work in the experiments. And they discovered that pigeons were remarkable workaholics. They would invest every ounce of their mental effort to solving the problems that the experimenters were posing. And we've found the same thing to be true. We've benefited from over 60 years of research, basic research on schedules of reinforcement and how you can get good control by environmental stimuli. And then beyond the basics, moved it up to explore, for example, pigeons' ability to categorize a wide range of stimuli. In one experiment, pigeons are able to categorize 16 different kinds of objects: cakes, flowers, fish, pencils, airplanes, cars, all different kinds of things. And to do this, we show them a picture on the screen. We ask, which of two buttons would you like to pack? One of them involves a little symbol for, let's say, cakes. And if they see a cake, they pack that. And if they see any other symbol, they don't. And through this means of providing reinforcement for correct responses, but not rewarding incorrect responses, the pigeons gradually learn to recognize these kinds of objects. In much the same way that computers come to recognize objects as well. But computers have, in some sense, the need to see not tens or 20s or 30s or hundreds or thousands, but millions of stimuli in order to come to correctly categorize them. And the trick, of course, is to respond correctly to stimuli they haven't seen before. Because you wouldn't say that you have a smart system if it could only recognize shoes, for example. If you show them photos of shoes they've seen before, you'd want to show brand new ones to see if they could extend what they had learned to new examples.
And we'll put some pictures up of some of these photos of what these pigeons were asked, I guess, to categorize. And like I said, when I was looking at them and trying to be like, how would I put these into two categories? It wasn't easy. I was, they all look so similar, and it was really interesting. And so that was your starting point with the black and white, with the bars and the thick bars and the thinner bars. Then from there, you kind of increase the difficulty of that. Did you guys do any kind of like, even just for fun at all? Like, did you guys have people participate in this at all, or was it all just for the study of the pigeons?
The paper that we've reported is actually the end of a series of experiments where what we did was we used these very unrealistic stimuli, these circles that contain black and white stripes that vary in width and their tilt. We chose those not because they're pretty, not because they're realistic, but because they've been used in experiments with people before. And almost all of the experiments that we reported in this latest paper had people in them too. So we knew how well people could solve some of these problems. In one of the tasks, not the very latest one, but one of them, the structure, the category structure involved two rings, concentric rings. And those stimuli were chosen because you couldn't cut the stimulus space looking only for the most tilted or the least tilted lines, or the widest or the narrowest lines. The task was much more complicated than that. And we actually found that by the end of the experiment, both the pigeons and the people responded very much alike. But en route to learning, the people enlisted strategies. They tried to sort the stimuli in terms of their tilt, and they tried to sort them in terms of their width, but that failed. And when those strategies, those higher order strategies failed, they reverted to the kind of simple associative system that the pigeon employs. And so, in some sense, the people's attack on these experimental tasks is different from the pigeons, because presumably pigeons don't have these higher order strategies or rules that they can deploy. They just associate which of two responses to make when they see particular stimuli. And through this rote memorization process, they ultimately succeed. People have to be taught to avoid using these higher level rules. And if they're properly taught by failure, since they don't work, to revert to the pigeon's method of learning, which they then do.
That's some logic.
We didn't ever test little kids. We wonder whether the little kids wouldn't have those higher level strategies. It's conceivable that children could actually do these tasks better than adults.
Sometimes you can't fill a full cup.
You know, that's an interesting way of putting it. I don't know if you've ever played a memory game with kids. There's an old one, Husker Du. Don't do it because the kids will beat you every time. They seem to be able to remember the locations and stimuli in a way that certainly eluded me. And I've seen kids, just beat the pants off adults. And I don't know what it is, but kids seem to have a much more particular way of learning. We seem to look for rules or some organizational principles, it doesn't always pay off. And it can be very embarrassing, I can tell you.
So where did you guys get your pigeons for this test? Were they just ferals or?
These are, I think you would probably call them duds from the homing standpoint. They're probably rejected homers. There's a farm in Iowa that supplies pigeons.
Oh, okay.
And the biggest supplier of pigeons is located in Palmetto, South Carolina. This is the most famous place, the Palmetto Pigeon Plant.
Yeah, that's still going. I read about that in an old American Pigeon Journal.
Absolutely, because they breed birds for their breasts. They're eating birds for the most part. White kings, white carnos, silver kings. We've stopped using those a long time ago. The homers work just fine for us.
I wonder if because especially in the racing world, they've got these super high-end bloodline, supposedly the smartest and the fastest and the top notch. I wonder if those would perform any differently on these tests, if even like their problem solving would be higher, or if that might prove the whole bloodline is a nonsensical thing or not.
No, I think it's a very interesting question. I'm not going to run out to Saudi Arabia and spend $30,000 for one of those birds.
Oh, come on, it'd be worth it.
It's true. I just read it. I just read about $30,000 for a pigeon.
Oh, they've gone over $1 million.
That's a clearance price.
Yeah, oh my God!
For over $1 million.
Oh no! Well, all right. So, if anybody wants to lend me one of those birds, right. I'll be happy to put it through the experiment. And I don't really know where I stand on whether there would be any likely difference. We realize that those birds, that selective breeding has probably brought about perhaps more highly developed structures in the brain, like the hippocampus and other navigational aids in terms of magnetic lines of force, and things that we are not even able to detect. I don't think those would do the bird any good in our kind of experiment, however.
That'd be another one too. It still fascinates me that they don't really know how birds do their homing, that there's all these theories and ideas, but I feel like there's more water in the bucket of the magnetical field theory.
Yeah, for sure. Put those little Helmholtz coils on the birds and see where they go.
Yeah, yeah, because we've even talked about we did an episode on how to sex your bird, and we were reading some of these old things, and if you swing a magnet over their head and it goes in a circle, I forget, one's a cock bird, and if it goes the other way, it's a hen, because they got magnets in their brain, and
They were pulling our leg.
yeah,
Yeah, boy.
I think we were getting fooled for sure.
I think so.
So you guys had these pigeons in there doing your test for a while. I mean, did anybody give them any cool names at all, or was it always pigeon A, pigeon B?
They're banded. They come with numbers, and we just sort of live with the numbers. I've worked with and published papers with 7 different species, not just pigeons.
Okay.
And there's something about naming the subjects. I prefer to have them at arm's length. I don't want them to become pets. And
Yeah.
and then you'll have the kids in the lab treating some of them better or differently than the others. I think it's best to not discriminate on the basis of docility, right?
Yeah.
So we take care of the ones that get the names and stuff a little different than the rest of them.
Exactly. That's what I tried to tell the kids. I don't want to see you walking around with one on your shoulder. Please, not save it for after you graduate.
With AI right now, it really is it's booming right now, and it's forever changing, and so your report kind of talked about like the similarities and like the way a pigeon would problem solve, and the way the AI works today, and that's where some of the people, I've read some articles, it's worded kind of differently, when they do the headline, AI is based off of how pigeons problem solve, and by the time you read the report, you find similarities there. Can you explain, how that is, like how the problem solving between the two are similar?
The pigeon and most vertebrates, animals with backbones and a cranial brain, most of these critters have the capacity to associate events with one another. So Pavlov would show a dog a flashing light, they'd follow it with food, and discover that the dog, although it at first salivated to the light, to the food, would then salivate to the light. And that is a basic association, right? Just like there's lightning and then thunder, right? They go in a certain order, you associate one with the other. That's one basic mechanism, what we call an associative mechanism. There's another mechanism that we're quite familiar with, like when you stick a fork in a light socket. This is probably something that is not to be repeated. I tried a second time. I got the same result, so I figured I'd learned enough in the process. I was only a little boy at the time. And that involves reward and punishment. So what reward and punishment do is to stamp in more firmly the associations that are simply the result of 2 events having happened together. So we have this kind of learning by contiguity and learning by reinforcement, the 2 to come together, and it's a powerful package, a very powerful package. And when programmers build artificial intelligence systems, they build both of those things in. They first build in a tendency to connect one thing with another if they've happened together before, and with a special form of feedback loop. Reinforcement is a form of feedback. It feeds back to the original association. It strengthens the association. Those 2 basic mechanisms are implemented electronically in a computer. It doesn't have to be in a computer. It can be in a robot. In the 1940s, when Skinner was fooling around with pigeons, various people in electronics were playing around with robots and seeing whether they could make them behave as though they were moving and behaving animals. And people have called them Anabots, animated bots, right? There's a long history of making mechanical things behave as though they're living things. We tried to turn the tables and treat the pigeon as though it were a machine, and if you will, build a computer model that then we hoped would emulate how the pigeon behaved. And Brandon Turner did that at Ohio State, and it worked. It worked quite splendidly. The one little story that I haven't ever told before, you're the first to hear this. I personally invented these ring tasks, the ones that people will be able to see on a screen. But after having developed it and tested it with people in pigeons, I discovered, to my amazement, this had been done before in artificial intelligence. People had chosen these concentric rings because they have the very property that would foil anyone or any system trying to just cut through the space of orientation and width. That you couldn't learn the task that way. You had to have a more complex structure. So they devised these concentric rings once again to test how powerful a mechanism had to be in order to solve it. And they ultimately came upon much the same solution that we did. So it really is a parallel path. The task that I devised to test people in pigeons, the task that AI people developed, programmers developed to try to challenge computing systems, it wound up being the same task. It isn't an accident. There's something that's profoundly important about building kinds of tasks that simple answers can't solve.
That is so cool. I mean, and yeah, that last one that you're talking about with the concentric circles, it definitely gets pretty complex at that point. And that's where you guys start talking about that next step of being able to separate and that order of thinking. I mean, that's
right.
That's really cool that you came up with that.
Of course, our next step, we've been really pleased, as you can imagine, and amazed. I mean, we were as amazed as well at how proficient the pigeons could behave. But this begs the question, what is it about the pigeon's computing system that allows it to do that? And here I was invited to give a talk in Germany to a group that has done the most important and impressive work on the pigeon's actual brain, to see to what extent they're able to find the neural mechanisms, the biological mechanisms that the pigeons actually use to adapt to their world. And so I hope to be heading off there in the fall and take the story to another level.
Wow, that's really cool. Have you ever seen those old-timey, Chris and I have been talking about getting one of these put together, those old-timey, they call them,
oh yeah,
what do they call those? Is it called like a chicken arcade where you play tic-tac-toe with a chicken or a pigeon?
Oh, that's a whole interesting side story. So I told you that Skinner had worked with pigeons in this really practical pursuit. It isn't always to try to turn pigeons into killers. The Coast Guard used pigeons to try to localize swimmers and life rafts that were floating in the ocean. When they had the bright orange vests on or a life raft, the pigeons were 90 times more successful at locating these color patches at sea. So some of his students, Skinner's students, decided, hey, we can do something even cooler. So they developed something, and you look it up on the internet, you'll find it. It's called the IQ Zoo. IQ Zoo. And the Brelands, Marion and Keller Breland, developed an enterprise to teach the dancing chicken to dance, to play tic-tac-toe, pigs to carry coins and drop them into, you guessed it, a piggy bank, right? And before computer graphics, you would want to teach animals tricks. And Skinner was a master of using reinforcement to have animals engage in behaviors that were, let's say at the very least, amusing, if not amazing.
That's exactly what we're gonna do.
Yeah.
There you go.
That's 90 times more efficient at spotting an orange life vest in the ocean.
But I have to tell you, the story had a tragic ending.
Oh.
Again, there were 3 pigeons involved, and they were put in a little capsule on the underside of a helicopter. But unfortunately, the helicopter had what in the trade is called a hard landing. and the landing gear collapsed, and the pigeons were crushed.
Ouch.
It's a drag.
That was the mega bummer. And at that point, the Coast Guard, who was sponsoring this, just abandoned the project.
It's too bad. I mean, in one bad landing, you could really have something useful, though, especially for that.
Absolutely. Well, pigeons have also been trained to do some strange things. In one project, Tom Verhoeven trained pigeons to peck misshapen capsules off the line at a pharmaceutical company. So that if anyone were slightly out of shape, the pigeon would whack it off the little conveyor belt.
See, like I was saying in the beginning, is because I've heard about where pigeons can look at two kind of x-rays or whatever and pick out, this picture of a healthy lung and this picture of a lung with cancer, and they can immediately get trained to find the ones that have cancer in it.
Yeah, we did that. That was our project.
Is that how you did? So that
was our project. To the best of my knowledge, it's true. We put our name on it.
that's I don't know. I feel like there's got to be some way to harness some of that. And, put them to work a little bit. They've been a beast of burden for thousands of years in different ways, and now that we're kind of really understanding them a little bit more.
Well, our plan was never to have them substitute for people, but to allow the pigeon to be, if you will, a first order screener for novel techniques. So, for example, although we weren't involved in this in any way, there are these 3D X-rays. So the question might be, are they more or less effective? Let's let pigeons take a look. They're a lot less expensive. After all, to have a really finely trained pathologist looking at stuff, they're going to charge $500 an hour. Pigeons, I have to say, work for, peanuts.
They're like $250 an hour, so
maybe so. Yeah, right.
They could totally be kind of the triage, like you're saying, like
exactly,
the sorter,
exactly. Stage one, right?
Yeah.
We did find, by the way, in other experiments that they could also detect abnormal ventricular formation. So the heart, if it was slightly misshapen. We also had them looking at these kinds of cardiograms, so to see how much perfusion was going in and out of one of the ventricles. They would either ventricles could open too widely or too narrowly, and in one case the blood would be wasted, in another case there'd be an insufficient oxygenation. The pigeons did fairly well there, not as well as humans, but again, all of these things might suggest some kinds of practical applications as well as the basic theoretical ones. So, we've been on all sides of this. We've been on the basics behavioral side. We looked at this connection to AI. We're looking at the biological basis of the neural systems of the pigeon to see how they accomplish these tasks. So it's been a really wide-ranging pursuit. Although my dad, every time I would tell him what I was doing, he would send me an article about navigation in pigeons. And I kept telling him, Dad, we don't do that. That's a very specific thing that pigeons do, right? It's their one of their savant skills. What we're looking at is something much more elementary. But I kept getting one newspaper clipping after another about homing.
Hey, I'll tell you though, if whoever figures it out, they're going to be known for it,
Oh yeah,
I've always known pigeons had these powers. My first pigeon chases my wife across the house. Doesn't bother me.
Oh yeah, well they can recognize people, that's for sure. But other birds do this too. In the news, if you look at the recognition of people by animals, crows are quite adept at this.
Of crows.
Well, I hate to tell you guys, but in the world of bird intelligence, pigeons still don't have the highest rep. It's always crows.
I'm taking that out, man. I'm gonna edit that out. We're gonna see that.
I just hate to burst your bubble, but honestly, I don't know how well crows would do. But I do know that we tried one of these experiments with baboons, because I have a collaborator who works with them. and they did really badly. And we've done it with rats. At first, some of our earlier work in collaboration with a colleague here at Iowa, rats did pretty well, but not when we gave them the really tough tasks. Then they fell short. I don't know what it is, whether the pigeons are just more steadfast, more persistent, or just what, but they keep working at it until they get it.
Oh,
You ever try pigs?
No, not pigs. Chickens, ducks, rats, mice, bonobos, monkeys, baboons. Yeah, that's enough. That's my IQ zoo.
That's cool. Yeah, definitely. Well, I'm going to look up that IQ zoo. I wrote that down here. They probably got a lot of neat stuff.
There's some really funny and fun video about it too. It really did exist. It really did.
Wow.
That's very cool. Have you ever thought about teaching a pigeon to play tic-tac-toe?
No, but I'll tell you something else. Pigeons can actually do something that baboons can do and that people can do. So I'm going to give you an example here. All right. Imagine a task in which you have a 4-letter word. I'm not picking a 4-letter word as a curse word. I'm just saying pick a word like door that has 4 letters. And then I can show you another 4-letter quotes word, but it doesn't a real word. Like, I mean, ODOR is odor. That would be another word, but ROOD, well, that wouldn't be a word, or RODO, that wouldn't be a word. So you can have things that are actual words and things that aren't words. Pigeons can, given training, learn with a wide set of words and non-words to hit one button if it's a word and hit another button if it's not a word. And you say, wait a minute, how in the world are they doing that? Well, now you give them brand new words and non-words that they've never seen before, and they can transfer. So it turns out in words, there are certain statistical regularities. There are probably very few words in English, in fact, there are none, that start with 2 I's, okay, no, that's not going to happen, or that end in 2 I's or 2 U's. I mean, there are going to be certain statistical properties that real words have that non-words don't have. So people can learn to categorize words and non-words. That's not a surprise, but so can baboons. And now we also know so can pigeons. So that's a trick that, is a more mental trick than tic-tac-toe or something of that sort. But I suspect pigeons could, if you set about to do it. All you need is a touch screen, and you can get an iPad, and you guys can get to work. That's all you need.
We're going to have to be calling you and having to pick your brain when we're putting our little machine together here.
That's right. Well, you'll just have to set it up, and you give them food when they're correct, and you don't give them food if they're not correct.
Yeah. And I mean, really, that's how, racer guys and a lot of the guys, it's, whenever I release my birds, I don't feed them and, I release them, and then they come back and they eat the food. And, that's one motivation. And then they got, the widowhood, and the racer guys got a handful of different ways to motivate a pigeon. But I think food is probably the most common. And, that's kind of like how Skinner did everything, right? That was all based on feed and doing it that way. Well, this has been awesome. This has been a really great talk. It's, hey, you know what? I feel a little bit smarter. I don't know about you, Chris, but I think my IQ points went up, at least 20.
Well, the real question are those pigeons' IQ points, and they've gone up. They've gone way up, right?
Hey, what is that's a cool question. What is the pigeon's IQ?
You would need a test for that, and certainly to be able to pass the tests that we've accumulated thus far. Only the pigeon has passed them. The very last task that we invented, the sectioned ring task, only a pigeon has solved it thus far. We've not tried it with people because it's not that we don't think they could learn ultimately, but who's going to take that amount of time and frustration to do that task? That is so hard. When you show that on the video, that is so hard. I couldn't put students through the pain and suffering of trying to learn that.
I was just gonna say, don't you got a lot of willing college students at your disposal? You can just, you guys have to do this.
Maybe there's something behind that.
Well,
Maybe it doesn't have the emotion. It doesn't.
Pigeons have emotions, but they also have incredible persistence. They'll keep working until they get food, and if by the way, if they stop getting food, they stop pecking too. So it's let's call it a razor's edge. You want to make the task solvable. You don't want to make it impossible, but you also want to provide sufficient incentive so that there's a reason to continue. But when you make a mistake, there's also a reason to correct it.
Okay.
Well, I'm going to wrap this up here. We've been talking with Professor Ed Wasserman from the University of Iowa. He's also the author of the book, As If by Design, How Creative Behaviors Really Evolve. And we'll be posting some of his the studies, the reports of the studies, and a video that really does a nice job of simplifying and summing up a lot of stuff too. We'll be posting all that up here on our Facebook too. You can take a look at it there. And Edward, really thanks for coming on with us and talking with us. This really has been a really fun thing to do and learn about. And like I said before, all those pigeon people always are bragging about what pigeons can do and stuff. Well, now we can cite you as our resource.
Now they really do have bragging rights.
Right, yeah.
There's no doubt about it.
We can back it up.
All right,
thanks,
gentlemen.
Ed.
Thanks for chatting with me.
Oh, thanks. This is